Hello, my name is Alma Meyer. I'm an undergraduate research assistant at Brigham Young University studying civil engineering. Today I'll be presenting on how the GEOGloWS-ECMWF Streamflow service was used to address water quality issues in Lake Atitlan, Guatemala. Lake Atitlan is a pristine endorheic lake in the volcanic highlands of Guatemala. The lake is a vital part of the economy of the surrounding towns. It is the second most visited tourist site in the country and the source of drinking water for about 400,000 inhabitants. Many also say that it's the most beautiful lake in the world. However, in recent years, Lake Atitlan has been contaminated by sewage and agricultural runoff. This has caused algal blooms that first appeared in 2009. At the 5th World Water Forum in Istanbul, Lake Atitlan was declared Threatened Lake of the Year 2009. This set of satellite images shows the algae blooms swirling across the lake from October to December of 2009. These algae blooms now unfortunately occur almost yearly according to the analysis led by SERVIR. This issue is only worsened by increasing population due to tourism. There are no sewage treatment plants in the region, so the lake is the ultimate receptacle of all waste. Through a project financed by the Inter-American Development Bank, the Sustainable Management Authority is working to strengthen local solid waste management systems to change the practice of waste discharge into Lake Atitlan. This is one of the main causes for eutrophication. In response to growing concerns over the future of Lake Atitlan, researchers at NASA-SERVIR have been working to use satellite images to understand and address the lake's water quality. The SERVIR Science Coordination Team, led by Africa Flores and with the support of National Geographic and Microsoft, is developing an algorithm that predicts when algae blooms will occur using satellite imagery data, artificial intelligence, and machine learning. But to make the algorithm work consistently, they were lacking data for one important variable: daily discharge volume into the lake. That data was originally obtained from the Global Land Data Assimilation System, or GLDAS, but a few months before their algorithm was ready to share with local stakeholders, GLDAS stopped producing the data at the frequency that they needed to produce useful forecasts. Thus, they were in need of a hydrologic model of the Lake Atitlan watershed to get the streamflow data needed to complete the algorithm. SERVIR's Science Coordination Team approached researchers at Brigham Young University, who helped develop the GEOGloWS-ECMWF Streamflow service. The Streamflow service's high resolution made this a great alternative to provide local data for Lake Atitlan. With the help of my colleagues at BYU, I was able to write a script that retrieves the Streamflow service's forecast data for the Lake Atitlan watershed and converts it into daily discharge volume. The script first retrieves the forecasts using the reach IDs for the 3 rivers shown here, the 3 rivers flowing into the lake, and then here are a few forecast hydrographs for these rivers. Since SERVIR's algorithm required discharge volume, we integrate the streamflow hydrographs using the SciPy Python package. This package performs trapezoidal integration, as shown here, and this script was easily incorporated into SERVIR's algorithm to predict algae contamination in Lake Atitlan. The forecasting system will aid organizations such as the Authority for the Sustainable Management of the Lake Atitlan Basin and its Environment, the Guatemalan Ministry of the Environment and Natural Resources, and the Atitlan Study Center at the University of the Valley of Guatemala as they develop and implement solutions to the contamination problem. These solutions will benefit the 368,000 inhabitants that rely on Lake Atitlan as a critical part of their livelihood. SERVIR's algae bloom analysis has already informed 2 key policy documents published in 2011, and this new algorithm will further aid decision makers as they address the water quality of Lake Atitlan. Just the simplicity alone of the Python script testifies to the success of the Streamflow service. Although the model is global and consists of more than 1.5 million rivers, it is accurate enough to be a powerful tool at a local level. The GEOGloWS-ECMWF Streamflow service gave SERVIR's science coordination team the data that they needed to complete their algorithm while maintaining its resolution. They were able to retrieve data for a relatively small watershed and solve a localized problem, helping them fulfill their mission of connecting space to village. Thank you all for your time.